Well, in this video, we'll talk about forecasting error in aggregate plans and also what to do once you come up with an aggregate plan. How do you disaggregate an aggregate plan? So that's the plan for this video. So in all the aggregate plans that we talked about so far, we were assuming that forecasts are going to be accurate as much as possible. So, but forecasts are never 100% accurate. There are always going to be forecast errors. And so, forecast errors must be considered. And one way to manage forecast errors is to carry something called safety inventory. Now, safety inventory is something we'll talk more about when we talk about inventory management later on in the semester. But safety inventory basically is you carry some extra inventory uh, to tide you over in case the errors in your forecast are much higher than expected, right? Now, there's also capacity of safety inventory. So, safety capacity, for example. So, you can use overtime as safety capacity. Say, for example, there is a particular month where you have a large demand all of a sudden, much higher than you expected. Then you could put, instead of saying that, okay, each worker can only do 10 hours of overtime, you actually remove that restriction and say that, okay, workers can now perform much more hours of overtime, right? So, or you can have extra workforce capacity permanently as farmer safety capacity. So you can either have safety inventory to manage these forecasting errors, or you can have safety capacity to manage these forecasting errors. But you have to realize that you will have to do one or the other because forecasting errors are a given. But if the errors are not very high, then you could potentially not have to manage it. You could just uh, you could just have a stock out for that 1 month and keep going. But if the stock outs are very high, there are obviously costs associated with the stock out, right? So that's how you handle forecasting errors. But more importantly, now that let's say that we've come up with we've come up with an aggregate plan. So let's say that this is the aggregate plan that we have come up with. So this is the original aggregate plan that we came up with. So we are going to start with 80 workers. So right at the beginning, we're going to let 16 workers go. We're going to get 64 workers. We're going to work with all of with them throughout the 6 months that for which we are planning. So this is the amount of inventory we're going to carry every day. There is going to be one month there where there is a potential for stock out, and that the same month when we subcontract. And because the number of workers we hire is constant, the production rate is also constant. And the maximum overtime is also obviously 640. That's given because each worker can work 10 hours, and there are calculations that they can do to calculate the maximum overtime. So given that this is the solution, what then, how do we disaggregate it? So because if you remember, when we first started this, we said that when you're making an aggregate plan, you're starting with individual families of items, and each of them have a separate material cost, separate revenue, setup times, batch sizes, and all of that. And what we essentially do is we aggregate all of this into a single number using the percentages that are percentage share of the units sold. Now, now we have to do the opposite process, right? So in this process, we have found out that the optimal solution is to produce 2,560 units every month. So if that's the case, how many of each of these different tools are we going to manufacture? So we know these percentages, right? So we know the percentages for each of these values. So for example, family A accounts for 10% of the total units sold. So if you have 2,560 units, then family, you will be making 256 units of family A. A quarter of that is family B, so 2,560. So it's 1230 or 615, so 615 units of family B, then some of family C. So you'd be doing 512 units of family B, 256 units of family D, 512 units of family E, and 378 units of family F. So these are the units that we're going to do based upon the percentage. So we take 2,560 and divide it up, the 100% of that, and divide it up amongst the 6 different families that we have, right? So with that, so what is the reason to do this? The reason to do this is because we have individual batch sizes, we have individual production times and all of that. We have to make sure that the plan that we come up with is feasible for these individual products. It might look feasible for a aggregated product, but does it remain feasible when we go from the aggregated unit to each of the individual SKUs that we have to actually manufacture? So let's actually look at that. So if you look at this, you'll notice that these are the number of units that we manufacture for these 6 units, because we know the different percentages, the 10%, 25%, and all of that. So we have all of these numbers here. So based upon this, we can actually calculate all of these different numbers that we need to calculate, right? So what are the numbers that we need to calculate? So let me quickly show you that. Right? Oops, I'm sorry. Right. So what we can do is we can take these production quantities, then we can calculate the number of setups that we will have to do. So how do I calculate the number of setups? I can take the production quantity, then I divide that with the average batch size. And we know what the average batch size is. So average batch size is something that is given to us in the data set. So if you look at the original data set, you will notice that the average batch sizes are given to us. So if you have to manufacture 256 units and the average batch size is 50, then we'll basically be actually making slightly larger than that. So what we do is we take these values, we take the values of the number of the production quantity, then we divide it by the number of setups. How do I get the number of setups? So sorry, I divide it by the batch size and then round it down to give me the number of setups. So 256 divided by 50, 256 divided by 50 will be 5.15 something, and then if you round that down, you will get number of setups equal to 5. So you have to set up family A units 5 times, family B units 4 times, 5 times. You can calculate the number of setups here. So once you calculate the number of setups, we can use the production time and the setup time per batch. You can add it all up and then calculate the production time. Now if you look at this production time again, these production times can also be calculated using the 10%, 20% numbers that we have, and then we reconcile those two numbers. So we go from individual units to the full plan. We make to the aggregated unit, then we make a plan for the aggregated unit, and then we break it down into individual units right here. And as you can see, based upon the number of setups and the production times, these things will work. So if you read it in the textbook, so disaggregation, so we know the ratio of expected sales is 2, so we can calculate the 256 units because it represents 10% of the sales. Next step is to identify the planned number of batches for each of these. So we do 256 divided by 50, which gives us 5.12. So rounding it down, it gives us 5. As a result, the average batch size of produced unit will be slightly larger than 50, which is about 51. So how do I know that? So if I divide 256 by 5, it'll give me about 51. So we similarly obtain the planned number of batches for each of these. So the planned number of batches for each of these. And then using that, we can check the feasibility by calculating the setup time and the production time for each of the planned batches. And then using that, we calculate the overall time. So if you calculate each of the production times and you add them all up, it comes to 10,231.4. So by looking at each of these individually, we need 10,231.4 hours in total. Now, with the 64 people that we have available, with them working for 160 hours a week, we have 10,240 hours in total. So we definitely have enough time to cover all the production that we need to handle. So we need 10,231.4 hours of production. We have 10,240 hours available. So this is a feasible schedule. If the total time turns out to be more than this, then you have to tweak this to make sure that the schedule becomes feasible. But the reason why we did not have an issue, frankly, in this case, is if you look at these percentages. If I go back to the old table and you look at the percentages, you will notice something interesting. So the percentages are actually well behaved. So if you look at the percentages of each of these units sold, the lowest is around 10% and the highest is 25%. And many of them are in the 10, 20, 25% range. Given that fact, because these numbers are so close to each other, there is not a huge difference between one product and another product. So if, let's say, one product accounted for, say, 60% of everything, and other products account for 20% and 10%, 20%, and something like that, then there is potential for a mismatch. But if all of these different products have similar percentages, but if the variation is not very high, then you're not going to have a problem going from aggregate plan to, once you disaggregate it into individual SKU units, right? And that's it. So that's mainly what I want to talk about in this video, the idea of how you go from an aggregate plan to a disaggregated plan, right? And checking to see if you have, if the schedule that you came up with is actually a viable schedule, right? So again, what are the steps that we went through to make sure it's a viable schedule? First, we calculate the production quantity. This comes from the fact that the optimal solution gave us 2,560 units. So if you're making 2,560 units and family A accounts for 10% of all of this, then you're making 256 units of family A. Now, we know that the average batch size is around 50. So if I divide 256 divided by 50, it gives me 5.12. And I round it down. It tells me that I have to set up this machine 5 times. So if I'm setting up this machine 5 times, then my production time is 5.6 hours. My setup time is 40 hours. And because I'm making 256 units, I can calculate in total that my production time is 1,433.6 hours. So I can make similar calculations for all the different families of units. And if I add them all up, that is less than the total amount of time that is available for us with the 64 people who are working for us, right? And that's the final reason why this is a feasible master schedule, right? And that's basically how we work. So in these series of videos, we saw the idea of aggregate planning. We went from how if you have individual families of unit, how you calculate data for an aggregate value. And once you calculate data for an aggregate product, you use that to create an aggregate plan. And once you create an aggregate plan, we saw how different values played different roles. What if firing was cheaper, and all of that. And also, what if there was a variation in demand? We saw all of that. And then once you've made an aggregate plan, how do you go from an aggregate plan to the individual family or unit levels? How do you disaggregate an aggregate plan? And this is how you do it, right? So this ends chapter 8. We will be doing chapter 9, which is an extension of chapter 8. I'm still going to keep it within the idea of aggregate planning. So what we're going to do in chapter 9 is we're going to talk about what happens if you're giving out sales. What happens in all of this? We are assuming that the sales price of a particular unit is fixed throughout. That is why we are doing this as cost minimization. But what if you have a sales price and the sales price is different in different months? Then how does your production plan change and all of that? So there are lots of interesting things to talk about, but we'll do that in next week, right? Okay, take care.